The negative exponent property. If we have a to the negative n, what that's equal to is 1 over a all to the power of n. And if we use the power of quotients property, what this becomes is 1 to the power of n over a to the power of n. And as we know, 1 to the power of any number is equal to 1, right? Because we have 1 times 1 times 1 times 1 n times. So the numerator just becomes 1, and the denominator is a to the n. So when we have a negative exponent, what the negative exponent property tells us is that that term can move down into the denominator, and the exponent changes from being negative to being positive. Right? We could put a 1 under that term, a to the negative n, and to change the power from being negative to positive, we can move it from the numerator into the denominator, and the exponent becomes positive. If we have a term in the denominator with a negative exponent, we can move it into the numerator, and the exponent becomes positive. Okay, so for the problems in our book, we don't want to have any negative exponents. Right, so we need to use the negative exponent property in order to ensure that our final answer has only positive exponents. Let's look at an example here. We have number 7, 32 divided by 4, right? And so we deal with that first. 32 divided by 4 is 8. So I'm going to say that's equal to 8 times a to the negative 8 minus 3. And here I am using the quotient of powers property. Then we have that multiplied by b times 3 minus 5 minus 5. And lastly, we have c to the negative 4 minus negative 2. Negative 4 minus negative 2. All right, let's go ahead and rewrite this. It's going to equal to 8 a to the negative 11, b to the negative 2, and c to the negative 2. It's negative 2 because negative 4 minus a negative 2 is negative 4 plus 2. Right? And then that becomes negative 2. So here we have our answer, but we have negative exponents. And like I said, our final answer should not have negative exponents. So how can we fix this? We could put a 1 underneath that expression, and we use the negative exponent property, which states if we have a negative exponent, you can move that term into the denominator and the exponent will change signs. If that term is in the denominator, we can move it up into the numerator and the exponent will change signs. So let's go ahead and do that here. It's going to equal to 8 in the numerator over the a needs to move down into the denominator. We get a to the 11, positive 11. B needs to move because he has a negative exponent, b to the positive 2. And c also needs to move because he has a negative exponent, c to the positive 2. Now we have rewritten our answer without any negative exponents, and I'm going to put a box around this. Let's go ahead and try it again over here on number 8. First things first, we deal with the coefficients. We have 5 in the numerator, 25 in the denominator, and we look for the greatest common factor. 5 is the greatest common factor, divides evenly into 5 and 25. So this becomes j to the negative 3, k to the 2, m to the negative 6, over 5 times k to the negative 4, m to the negative 2. And what did I do here? I divided 5 by 5 and 25 by 5. Right? 5 divided by 5 becomes 1, so we don't need to place the 1 there. And then 25 divided by 5 is 25. Is 5. So now we can go ahead and deal with the exponents. Right? So this is going to equal to 1 over 5. 1 over 5. Okay. Now j does not have a is not in the numerator and the denominator. Right? So we're going to keep j at the top in the numerator. Say j to the negative 3. And then we have our k in the numerator and the denominator. So we'll say k to the power of 2 minus a negative 4. 2 minus a negative 4. And then we have m to the power of negative 6 minus a negative 2. Alright. Here we have two negatives, so this becomes positive 4. 2 plus 4. Here we have two negatives, this becomes positive as well, so it's a negative 6 plus 2. Let's go ahead and rewrite this out. 1 over 5 times j to the negative 3, k to the 6, and m to the power of negative 4. Alright, so now we need to see where we want to put each of these variables, whether they should be in the numerator or they should go into the denominator. Okay. So let's go ahead and do that. The j to the negative 3 needs to move from the numerator into the denominator so the power can become positive. So here in the denominator I have 5 times j to the power of 3. The k stays in the numerator, k to the power of 6, and the m needs to move to the denominator so its power can become positive, m to the power of 4. And this is our final answer here.